In most cases, neurosurgeons will try to remove as much of the brain tumour as possible if it's safe to do so, and crucially, that means avoiding damaging the healthy bits of the brain. And this remote-controlled robotic arm helps with that. Through a tiny hole made in the skull, a tube which houses a laser can be fed to the exact spot using an MRI scanner. The laser is twisted towards the direction of the cancerous tissue, while the healthy tissue on the other side is left untouched. This is one of the first patients to use the system. The initial results appear positive. But the man in charge of brain cancer research here doesn't want to stop there, and there's a good reason why.
My father was very supportive, and he told me, well, there are other skills you have. And ironically, the man who helped me, or motivated me to go into medicine, ended up having a brain tumor, glioblastoma. And it was about 8 years ago where actually he asked me to do surgery.
Dr. Badi's father died a few months later.
That's when I realized that being a neurosurgeon is not enough. It has to be through science, technology, and that's one of the reasons I came to City of Hope.
To do that, Dr. Badi is going beyond stem and T-cell treatments to help develop special nanoparticles that attack cancer growths. And he's adapted new equipment used to help deliver them straight to the front line. By removing the remaining burnt tumour after the initial treatment, space is left inside the brain for the nanoparticles to then be delivered. Either drugs or these designer cells then go to work fighting any remaining cancer threat. But tumours often re-emerge after treatment. So Dr. Badi's team wants to direct their special fighter cells once they're inside the brain. By attaching microscopic magnetic particles, he hopes to move the treatment to any area of the brain, simply by using a magnet. Magnet-guided treatments are attracting serious attention. 3 months ago, Google X, the scientific research arm of Google, got to work on a similar idea. Both teams expect new treatments in 5 years' time. Obviously, the key thing about targeted treatments is knowing where the target is. So down the road, another research centre is developing an illuminating solution to the problem, snappily entitled BLZ-100. So this is the cross-section of the brain of a mouse with a tumour. It has the solution BLZ-100 already in it. We can't see it because it responds only to near-infrared light, which is why it needs the special camera. And when we place it underneath, well, that's when this technology really starts to shine. The solution, based on a peptide found in the venom of deathstalker scorpions, naturally attaches itself to tumours. Researchers have added a fluorescent dye, invisible to the naked eye, but seen by a special single camera using near-infrared light.
Near-infrared light penetrates much deeper into the tissue. For the first time, surgeon will be able to actually visualize where the tumour is. You cannot go wrong. After that, you cannot say, oh, well, we couldn't take all the tumour out because we didn't know where it is, or we took too much out because we don't know where the tumour ended. So now you know exactly what you're taking out.